Recall that with atomic vectors, we could assign names to each element of the vector, allowing us to use those names in place of the numerical index for getting back to a particular element. Well, a list is just another kind of vector, so we can do the same thing. In fact, it's really common to use names for the different elements of a list because each element can be a different data type. And in order to remember what all those data types mean, it's much easier to use a name for each element as opposed to just a generic number. Also, we have another way of indexing with a list that we didn't have with an atomic vector. We can use the $ notation. So ultimately, if we want to get at the contents of a given element of a list, we might put a name in double square brackets, but there's a shorthand for that, and that's the $ operator. So if we put a $ with a name after it, we can do the same thing. Let's look at how this works in a simple example in R. Let's say that we're going to create a list called shape list. We're going to use the list function to create it. And we want to keep track of different names of shapes, different types of shapes, and how many vertices they have. So let's say we have a element that we're going to call shapes. And let's say we have two different shapes. We're going to talk about a square and a triangle. So that's our first element, and then corresponding to that, say we want to keep track of how many vertices they have. So I'm going to spell it correctly, an element called vertices, and this will be numeric. A square has 4 vertices, and a triangle has 3. So we now have a list called shape list. Notice that when we name the elements of a list, that instead of the numerical index in double square brackets, the actual name of that index shows up. So we have a $ shapes here, indicating that the first element is called shapes. And then in that element, or what that element is referencing, is a vector of characters. And we have a character string square and a character string triangle as the 2 elements of this vector. Then we have the second element of our list called vertices with the $ vertices, and that is a numerical vector with the values 4 and 3 corresponding to 4 vertices on a square and 3 vertices on a triangle. So let's talk about the different ways we can use these names to get at the individual elements. I can do a couple of different things. I can do the single square brackets and get the shapes element using the string shapes. Again, this is the single square brackets, so just like when we're using numerical indexing, I am asking for the reference that is in this element called shapes. In that case, I'm going to get a list back, and it's going to be another list, and it's going to have a shapes element with square and triangle. And I'm only asking for that one element, so I'm not getting the vertices element. I could also use the double square brackets. So if I use the double square brackets, remember that I'm asking for the contents of that reference. In that case, I'm not going to get that $ shapes because I'm not getting a list here. I'm getting a vector or a character string vector that is the contents of that element of the list. I can confirm this with the type of, if I do a shape list single square bracket shapes, I should get another list because it's going to be a list with one element corresponding to the shapes element. If I do a type of on shape list with double square bracket shapes, then I'm going to get a character vector because that's the contents of that element, not just the reference. And this is where the $ operator gets convenient because another way to do the same thing as the double square brackets is the $ operator with shapes. And again, that gets me the shapes element just like the double square brackets did. It's just a little bit easier to type. I can also do that for the other element, vertices, and get the vertices element, the numeric vector that's in the vertices element. In order for R to be giving us this feature of naming different elements of a list, it must be putting these names somewhere in the data structure so it can keep track of which names belong to which elements. this gives us an excuse to look a little bit more carefully about how R handles this. Now, every object in R has attributes, or it may have attributes. Both vectors and lists have attributes, as well as all of the other data types that we're going to talk about. And it turns out that the attributes are a list of information about a given object. And you can get at that list using the attributes function. So the attributes function can access the attributes of any R object in a list, and they're going to be specific elements of that list. In this case, the element is going to be called names that keeps track of the relevant information about that object. So let's go back to R and think about what that looks like with the shape list. If we do an call attributes function on our shape list variable, this shows us that attributes are a list, and this list has one element. That element is called names, and the contents of that element is a character vector. And the character vector are the names that we gave it, the shapes and the vertices. And this is going to be a vector of character values that are the same length as the number of elements in this list. In this case, there's two, the first one being shapes, and the second one called vertices. So because attributes returns a list, we can get at the individual elements of that list with the $sign operator. So if I want to see the contents of names, then I have this vector, character vector of the names called shapes and vertices. Notice I'm not getting a list anymore. I'm just getting that vector. And I can actually use this to change one of the names. So say I want to change my shapes to be shape names rather than just shapes. Now, if I look at my shape list, my names will have changed. And I'll have shape names as the name of my first element and vertices as the second element. There's one other function that you can use to quickly get at the names of a given object, and that's the names function. So this is just shorthand for allowing you to get directly at that element of the list. So if I look at the names of shape list, I will get shape names and vertices. So the attributes function is another one of those really important functions to understand for exploring data structures in R. In this particular case, we're looking at the names that are an attribute of a named vector, but ultimately we're going to be using attributes a lot in this class to explore data structures and understand how to use them.